This lesson will enable you to solve problems involving joint variation. What is joint variation? You might ask, what is joint variation? Okay. One variable will depend on two other variables in a joint variation. Yes. So sometimes we will talk about this in terms of a quantity that varies with a product of two or more other quantities. So that situation or that kind of variation will be called a joint variation. Notation. So joint variation. So the statement varies jointly as x and z is expressed as, so if we say y varies jointly as x and z, we are going to express this in a lovely way. I don't like red. Okay, green. So we would say y varies jointly as x and z in that way. So y varies jointly as x and z, but with joint variation, you have to look at the given situation. You will have situations where you have one variable is directly joined to another, and the other variable is inversely joined to another. So the notation won't always be as I have written. I have written this in just to give you an idea of where we're going. So the above statement can be written in equation form as y being equal to k x z. Let's move on and look at some examples. Okay, so not example 2. We have two examples that we'll look at. We'll start with example 1. Given that p varies directly as q and inversely as z, if p is 2 2/3 when q is 6 and z is 3, find the value of p when q is 12 and z is 4. This is the exciting part because we are trying to now solve problems that you will encounter, especially in exams. So these are the kinds of problems that we need to decipher and work out the values that have been asked. So let me not talk too much. So let's look at the question. We'll look at this statement here. P varies directly as Q. So in notation form, we'll say P varies directly as Q. However, P also varies inversely as Z. So how do we connect these things? P varies inversely as Z. So how do we connect these two things? How do we connect? Oh, wow. Want to move fast. How do we connect these two things? So this is how we are going to write this statement. P varies directly as Q and inversely as Z. So any variable that is inversely connected to another will be the denominator. and the one that is directly connected to the other will be the numerator. So in equation form, this will simply be written like that. So we have found a general equation that is connecting Q and Z. So we now need to find an equation for this situation, this particular situation, not the general one. So in doing that, we need to find the value of K. So we are going to write P as P over 1, and we'll rewrite the right hand side. We are going to cross multiply. When we cross multiply, what we're going to have is 1 multiplied by KQ. So it will be KQ. P multiplied by Z will be PZ. We just need to have the K on the left hand side. So we are going to divide both sides by Q. The Q goes, so Q in Q1, Q in Q1. So the Q on the left hand side goes, and what we are going to have is this situation. All right. So the next thing that we need to think about is to substitute P is given, Q is given, Z is given. We need to find what K is. So we substitute those values in our equation. When we write 2 and 2/3 in improper fraction form, we are going to have 8 over 3. So 8 over 3 is going to multiply by Z, which is 3, over Q, which is 6. When these two multiply, the value will be 8 over 6. To write this in its lowest terms, the highest common factor is 2. 2 in 8 is 4. 2 in 6 is 3. All right. The equation for this situation, we substitute this in this general equation. So we'll have P being equal to 4 over 3 Q over Z. This can be written like that. Okay. So now we get into the final part of this question, and the final part of this question wants us to find the value of P when Q is 12, Z is 4. So P will be equal to 4 multiplied by Q is 12, Z is 4. 4 divided by 4, 1, 4 in 4, 1. 1 times 12 is 12. 12 divided by 1 will be 12. So our P is equal to 12. We move to the next example. So for the next example, we do like we have been doing previously. What we've been doing is you are going to pause your video, work out this problem, then verify your answers with what I'm going to do. Example 2 reads, given that y varies directly with x and the square of z, and y is 3 when x is 2 and z is 3, find the constant of variation k. The equation for this situation, that is part B, the value of z when y is 2 and x is 1. We start with part A. So let's read this question carefully. y, oh, y varies directly with x. Y varies directly with the square of z as well. So we're going to write this in notation form as y varies directly as x and the square of z. So we square the z. In equation form, this will imply that y is equal to k x z squared. So we now tackle the question. It's not soccer, but it's math. We also do tackles in math. So k, the constant of variation, is what we're looking for. So the term on the right hand side goes to the left, the one on the left goes to the right. So we are going to divide both sides by xz squared, xz squared. The whole expression will cancel out. You have k is equal to y over xz squared. In the question, you've been told that y is 3, x is 2, z is 3. We substitute those values. Where there's a y, you put a 3. Where there's x, we put a 2. We multiply 3 like that. So 3, z is 3. So you square it. So we will have a situation of saying 3 divided by 3 is 1. 3 divided by the square is just a 3. So you have 1 in your numerator and 2 by 3, which is a 6 in your denominator. So k is 1/6, or k is equal to 1 over 6. So we are done with part A. Part B, the equation for this situation. So the equation for this situation is very easy. What we are going to do is we're going to substitute 1 over 6 for k. So the general equation is y, it's here. So where there is k, we're going to put 1 over 6 and rewrite the other variables. We move on to C, part C. The value of z when y is equal to 2 and x is equal to 1. So in this situation, we've noticed that the equation of this situation, the subject of the formula is y. We need to make z the subject of the formula, like what we've been doing in the past. We move the right hand side terms on the left, and the left goes to the right. So what do? We multiply the multiplicative inverse of 1 over 6 on both sides. So when we multiply the multiplicative inverse of 6, which is 6 multiplies by this. That's where we're starting, so that you can get clarity. 6 goes, so you have this situation. This is a square, so you have 6y. We just want to have the z term on the left hand side. We divide x on both sides. So what we are going to have is x cancelling out. So we'll have, let me write it on the top, z squared will be equal to 6y over x. At this stage, we can start substituting the values. We'll deal with the square of z after the substitution is done. So part C is saying the value of z when y is 2 and x is 1. Where there's y, we put a 2. Where there's x, we put a 1. That's how substitution works. Over 1. 6 by 2, 6 multiplied by 2 is 12. 12 divided by 1 is still a 12. So learners who are too quick will end here, but the question is not asking for z squared. The question is asking for, what is it asking for? It's asking for a z. So what we need to do is to introduce the square root on both sides. Square root on both sides. So we'll have z is equal to positive or negative square root of 12. So this is our result there. You might be wondering, how on earth did we introduce a square root, and how can a square root cancel with a 2? So this one is left in third form. It's fine to leave the answer in third form like this, but you can leave it in decimal places decimal number if that's what the question demands. Now the big question is, why are we using the square root to cancel out there? Why? Okay, so that is where I will leave you. I want you to think about that question so that you will have curiosity and you can do a bit of research. It doesn't hurt. And the best way to learn is to maybe crack your head a bit in math. You can leave a comment so that you can help others if you know why, the why question there. Otherwise, I'll leave you here. You can like, you can subscribe, you can leave comments, and we'll see each other virtually, of course, in the next one.